All right, so today I want us to look at this question with sample size real quick. Suppose that you wanted to estimate P, the true proportion of students at your school that have a tattoo with 95% confidence and a margin of error of no more than 0.1. What's the minimum number of students that you need to survey? The idea behind this problem, this is an interesting problem that involves part of the confidence interval formula. This is where we can decide how many students or how many subjects that we need to have in our study in order to be within a certain margin of error of the thing we're trying to estimate. In this case, we're trying to estimate that true proportion of students that have a tattoo at your school. Okay, so how many do I need to survey? This is an important question because a lot of times with studies, there's a certain cost that has to go into it. Like, you know, if you're paying somebody to actually go out and do the surveying, or having to pay for some sort of software or something to be able to run the analysis on it. I don't know. There could be different costs or whatever. And there could also be a cost for, like, per, I don't know, there could be some sort of cost that's based off of how many you're going to survey. How long do I need this survey to go on for, and those kinds of things. So it's also just important to know, if you want to be within a certain margin of error, you want to find out how many people you have to survey. Okay? So when you're looking at this problem, the first thing you want to do is calculate your Z star, because that's going to be involved in your margin of error formula. So you calculate your Z star. Okay? In this case, we're dealing with a 95% confidence interval, so if I draw my normal curve, 95% is in the center. How much is on the ends? Whoops. 95 is here then.
0.025.
Yeah, so it'll be 0.025 on each end. Because this 2.5% needs to add up with this 2.5% to make 5%, and then the 95% is in the middle. Okay, I did not do a very good job drawing that very symmetric, but you get the gist, I think.
Yeah, you did.
Okay. Well, my lines are kind of, that's where I messed up. The curve itself's not bad, but the line, where I place the lines, is a little bit off. Anyways, so you want to run your inverse norm to find your Z star. Y'all remember doing this, right? A little bit.
I've slept.
It's a Z score. We're looking for a Z score here because this is centered at 0. It's got a standard deviation of 1. We use the standard normal. So we're looking for a Z score, basically, of where this is at right here. We're looking for the Z score of that right there. Which really, we actually really want this one, but if we find this one, it's negative of that one. Okay. This right here is technically negative Z star. So if we want Z star, it's just the positive, which is over there. Okay, so where do I find inverse norm on the calculator?
You do, is it bar? No.
Yeah, second
It is
bars.
bar,
Second bars.
and then it says inverse.
Yeah, number 3. It asks for the area, that's 0.025.
Wait up, how did you inverse norm?
Here.
Second bars.
Second, bars, 3.
Yes.
Enter. Now wait a minute, last time I did this, it kept messing up. It wouldn't do the thing.
It should.
You got your area, right? It says area.
Yeah.
That's where you're going to put 0.025.
Okay.
And then you're going to leave your mean as 0 and your standard deviation 1. That's what it defaults to, and you're going to go down and paste it.
Okay.
So that it looks like this.
0,
Yep.
3,
On your screen, you hit enter, and it gives you 1.96.
I got negative 1.9.
Well, yeah, but that's the negative Z star, so we want Z star, we'll take the positive.
Cool.
Okay? So you'll get Z star to be 1.96. You get a negative 1.96 with that, but then you make it
I
positive.
didn't get
Okay.
Is it 1.95?
What's this?
Okay, so we go to second bars.
Okay, if you're gonna do center, you put the center area in there. Remember yours is
You're
different.
right, okay.
You get to do that.
I
You need to
got
do
you.
it one way or the other, not get them confused. I'm gonna keep probably saying it this way, Ainsley, but you're gonna have to remember to put the center area. You need to make note of that somewhere.
Yeah, I do.
So that way you don't forget that. Those CE calculators are different. They'll do that.
I'm lost.
Don't worry about it.
Okay.
Don't
Did you
worry
get
about
this?
my problem.
No, because I don't know what I'm doing.
Oh,
The second
doesn't
bars,
know
I
how
go
to do it
to
on
the
the
third
couch.
one.
not inverse norm.
Okay,
It's gonna, oh, your calculator, you need the newer operating system.
yeah, you know that.
Yeah. And
I keep forgetting to tell you.
Yep. Well, I think that's left the board. Yesterday. Did I give it to you? I've never given it to you?
No.
Ooh, they're gonna have chemistry.
Oh my god, it would be fun.
They are. Calculators are having chemistry.
Don't be talking about my calculator like that. It's her first time. She's scared. She's nervous. Don't do her like that. Don't call her out. She ain't ready.
That's fun.
That is weird how you can like see that.
You gotta have the one calculator, teach the other one how to do it. 'Cause it's
Yeah.
experience.
That's right. Wear your mask
She-
properly,
She did a
John.
little experience. You know.
All right,
Oh, I thought they were supposed to do the thing.
They are.
so once we
I
get,
don't.
okay,
I'm
so we got
Sunbird.
Z star.
Sunbird. I got a Sunbird.
All right,
I do it.
we look in the problem here and see if we have a guess for P. Because our margin of error, the margin of error is equal to the Z star times the square root of P times 1 minus P all over N. Technically, those are P hats, but whatever. Alright. It's the part of the confidence interval formula, guys, that we did on Friday. It's the part of the confidence interval formula, but it's the part that's on the right-hand side after the plus or minus in the formula. Okay? Usually it takes a few minutes.
It's still receiving.
Okay, good.
It's at 50%.
This takes a little while. Sometimes sending other things are quicker, but this one always takes a little while.
Takes a minute.
Yeah. All right. So the formula, as you can see, this is the margin of error. N's the sample size. That's what we're wanting. We want the sample size. That's what we're looking for. But we don't really know what P hat is. So this is where we either have to look at the problem. If they give us information about a previous study or a pilot study, we can have that as our guess for P hat. But if they don't give us any information about P or P hat, then we automatically have to use 0.5, 50%. Because at worst case, it's a 50-50 shot when you ask somebody, do you have a tattoo? 50% as your P value will give you the greatest margin of error. So to be on the safe side, if you have no information about P, you automatically have to go with the greatest possible margin of error, which would be 0.5. Okay, that's going to help yield that biggest margin of error. Sure, we're going to still try to get it below 0.1, and we will be able to with a certain sample size. But we're automatically going to fix P to be 0.5 if we have no information about P. And as you read this problem, does it tell me anything about a pilot study or any previous information in there?
It just says no more than.
It doesn't really say anything about what P could be. So guess what? We have to use 0.5 then as a guess. Those are your two options, and I talked about those yesterday in the Edpuzzle video if you watched that. If you don't know P or know anything about P, guess 0.5. But if you have some previous information, then you use that previous information. It'll be obvious in the problem. You'll either have something or you won't. I mean, I think it'll be kind of obvious. So we're gonna guess p hat to equal 0.5. So our margin of error is our z star times the square root of p hat times 1 minus p hat all over n. This margin of error, we want it to be no more than 0.1, so we want it to be less than or equal to 0.1, because we don't want it to be no more than 0.1, so no more than 0.1 means not greater than, less than, but it could be 0.1, no more than greater, I mean, no more than 0.1, it can equal 0.1, but no more than that. That's it. So we use less than or equal to 0.1. 9 times out of 10 with these, you're gonna want it to be less than or equal to anyways, because, I mean, why would I say, I want the margin of error to be greater than 0.1. I wanna be more wrong than 0.1, that makes no sense. Okay, so it's always, most always gonna be less than or equal to anyways. Done. Now go to second bars. Go to number 3.
Okay.
Now it should have the fancy,
For this,
yes,
Okay.
your area will be 0.025, and your mean is 0, and your standard deviation is 1, you go down and paste it,
with this,
and then hit enter. It should give you negative 1.96, you take the
Yeah,
positive though.
I got negative 1.95996.
Yeah. That's negative z star on this end.
Okay.
We always want positive z star, so we always take the positive. Because of symmetry, this will always just be positive whatever you get.
Yeah, okay.
Did you forget a piece?
Attendance.
Yeah.
Oh my gosh. Save my chips right now.
Don't give me one yet.
Hello, how are you guys
I'm sorry, my Chromebook was taking 15 minutes to get logged in, and I forgot to even do it.
Okay, and I still maintain
But then
another.
they're little.
I'll let them have talk.
All right. So,
Is Abby the only one on the Google Meet?
yes.
Love you, Abby.
Might not be able to hear us.
Love you too, Olivia.
As soon as I said that.
So, plug in your z star 1.96, plug in your p, which will be 0.5, that's what we're using to guess. So it'll be 0.5 times 1 minus 0.5, really that'll just be 0.5 times 0.5, right? Our unknown is n, that's the sample size. That should be the only unknown in our problem. That's why we had to use 0.5 as a guess for p, because we had to plug something in for p.
Well, we'd have 2 unknowns if it's not good.
What now?
I said, cause then we'd have 2 unknowns.
Yes, and we couldn't solve that then, unless we had another equation with those same 2 unknowns, and, well, then it would be a system of equations, and,
Oh, let's
well,
not get
let's
into
not even go
that.
there. Okay,
Hey, Mr. Crabtree.
Hey.
Okay.
Lindsay, tell us what they're saying, Lindsay.
Try to keep it dark. Make sure it's right. Make sure we're safe.
Oh, it's Abby. This is your fault, Abby.
What did I do?
And is that rounded up, that's the front, right?
right here.
Okey doke. Hello.
Hi.
Would you hold that right there in the middle,
Yeah.
please?
Yeah, because.
Hang on. Right on. Any movement 1 inch and that would have been it.
Logan, why didn't you move?
My bad.
Yeah.
Did you
Don't tell me y'all wanna get out of here.
Yeah.
No.
Never, no.
Well, this should be a good class.
Yeah.
right? AP stats?
No, this ain't even the right class. I found out that I have to take another stats class in college.
Really?
Yeah, this is a different one. For the one I need, there's like two, this is like a family consumer stats class or something.
Oh
like
my, a
transfer
wasted
to.
time, huh?
Pretty much, but at least I'll know a little bit.
Well, that's why I always tell y'all to check
It should
it.
help you.
Yeah.
I
I
don't
should
care.
always, that's why I always tell y'all to check it.
Absolutely.
Well, he told me that he thinks it's the right one, and then he came back, he's like, yeah, I don't think it's the right one. And he sent me this thing, and it might work. he
Sometimes
said.
you never know.
Yeah, he says he's gonna try to
They're
get it.
very,
He's
yeah.
gonna try to get it to where it.
Sometimes
works
you
for
can,
me.
they'll make an exception if you ask really nicely.
And if
Yeah,
you
he's
do well
very
in here, even if you have to take it, surely it'll be an easy A when you get there.
Hopefully.
Okay.
Yeah.
Any group work, anything? Did you
Nope.
work one-on-one?
No.
All okay. Thank you all. Sorry to interrupt.
Plus I'm vaccinated too.
Pardon?
I'm vaccinated,
Me too.
so
Y'all got them shots.
for 90
Oh,
days,
me
I don't
too.
have, 90 days, I don't have to quarantine according to the regulation,
That's exactly right.
so.
But we have to ask anyway.
Oh, yeah, I know.
Thank you.
Technically, anybody can get their COVID right now.
Hey, I got a question.
They've lifted up all regulations.
Do people on death row know that they died?
What?
I said, do people on death row know the
Because
date that
if
they're
you're
gonna die?
within 6 feet, they'll
A lot of
send you
times they
home
know their
because
execution
Abby
date,
has
yes.
COVID. So, like,
Are you
if
reading the
she
Green
tested
Mile?
positive for COVID,
Oh,
they
okay.
would send.
Is it
she would
good?
be here, and they would
I know
come in
I like
and
the
they
Green
would
Mile.
have to
It's
go.
kinda
I'll
sad.
never watch it.
They would send
The
you home
movie's
to
kinda
go,
sad.
like,
What?
It's kind of a
they
sad
wouldn't have
movie.
even been like,
It's
sorry,
very-
you've got
But it's good, it's like heartwarming.
All right, all right, back to this. I love how all of this is gonna be on my video. All right, back to this.
Oh,
Yeah,
sorry.
hush, everyone.
It's just Abby.
All right, anyways, back to this, guys. All right, we gotta do a little bit of algebra here. You know how much I love this.
I can do algebra.
To solve
Me too, that's the-
this equation, actually, you can kind of, I even had someone, I don't know about how you all feel about it, but I had somebody in the other class really say that, like, with confidence intervals, it kind of felt like math. Because you're actually using a formula and you're plugging in and solving
It's about
Yes.
time.
for something. So, you know, it was a little more like that instead of, you know, let's just think about things or answer some thinking question or whatever. So it felt more like math. So you've got 1.96. I'm gonna break this square root down into the square root of the top. And I'm gonna go ahead and write that as 0.5 times 0.5. You see what I did? 1 minus 0.5 is just 0.5. And that's all over the square root of n. That's using a property of radicals. If you take the square root of a fraction, it's the square root of the numerator over the square root of the denominator. That's less than or equal to 0.1.
Isn't there an in button?
What?
I said, isn't there an in button on the calculator? Or we should.
There isn't.
should be on-
I mean, it's on there, but that's if you're in a different mode, and that's not what we're looking at. That's for sequences.
Oh.
That is not what we're doing.
Yeah,
That was not what.
Okay, you can't really use the calculator here. You gotta do a little bit of algebra first before you can plug in the calculator. You can use the calculator to start doing here. Alright, we don't have the n isolated. We gotta get the n by itself, the variable by itself. We know this from algebra.
Times it.
Okay, so we'd have to multiply both sides by the square root of n.
I can't even see geometry.
I'm sorry.
What about
I'll move over here in just a moment.
in conception?
Okay, I'll multiply by the square root of n. Or you're welcome to stand if you want to. If that'll
Oh,
help.
right,
I get it.
It won't take me very long before
yeah.
I.
You're good, you're fine.
Alright. So we multiply both sides with the square root of n. The square roots of n cancel out there. And I'm going to get 1.96 times the square root of 0.5 times 0.5 is less than or equal to the 0.1 times the square root of n. Now we need to get the 0.1, we need to divide by that to get that over here, right? Because we want the n by itself eventually.
It's like getting a glimpse.
So we're gonna divide by 0.1
It's just- it
on
looks-
both sides,
I know what's happening right now.
okay?
I have no idea what's going on, but I'll
What?
pretend I do.
Where have I lost you?
No, I said that it's nice because I can understand what's happening now, as opposed to all the other times it's like.
I hate
I'm sorry.
No, it's not your fault. It really is just mine.
I hate
You
It's
see
just
what I
stats
kinda
in
like?
general, okay?
I kinda like this though, cause it's,
It's nice.
and we're gonna still, we're gonna be dealing with some confidence intervals for a little while now, so you're still gonna have some of these. Like in the next chapter, we're gonna do something else, but you're still gonna have we're gonna see confidence intervals again. Alright, so, we divide by 0.1 on both sides. That's gonna get square root of n by itself. I'm gonna move over to this board just because I've got low on the board there. Okay, so here's what I got. 1.96 times the square root of 0.5 times 0.5 all over 0.1 is less than or equal to the square root of n. If I want just n then, how do I get rid of that square root?
If you want just n.
Yeah, because I want to get n by itself, but it's got that square root on it.
Something
Wait
with
a
one.
second.
Yeah, I'd raise it to the, I'd square both sides. Square this, square all that. That's gonna give me n is greater, or well, all this jump, whatever this is less than or equal to n, in other words. N is greater than or equal to that then, if you read it backwards. So I'm gonna type all this
In the cow.
in the calculator. Now that I've got n by itself, all that's being squared, and I'm gonna type that part in the calculator.
Don't say it yet because I'm gonna see.
I'm not gonna say anything, I'm gonna see if you get the right answer.
Okay.
I'm still writing stuff down.
What's wrong?
I'm still writing stuff down.
Okay, I'm sorry.
No, you're fine, I'm slow.
Well, did you stop and like, was watching?
Yeah.
Well, that's what you
Okay,
need to do
let's see.
sometimes. I'm not writing the answer, I'm just writing the other side, which has n by itself already. See what you get.
How do you square square root on the calculator?
I typed that whole fraction in parentheses and squared it on the outside.
Okay, then
That way it looked like that. Now the calculator may take the parentheses away after you do that, but it's the same thing. It converts your print
Okay,
sometimes.
so we
a
would do
little bit.
it like, okay, I'm lost.
What?
I put it in the calculator, so like.
I'd put this in as a
How
stacked
do you
fraction. If you
split?
alpha y equals number 1,
Okay,
stacked fraction,
okay, so put like.
in
the-
parentheses.
Okay, so like
Parentheses
put my
were in.
parentheses and then put it in like a fraction.
Yes.
And then, okay,
I
So like
type
this.
all that
Do
in.
that and then two.
That's just the easiest way to do it.
okay. Yeah, okay, I'm good now.
With the square root in the top there.
I'm sorry.
You would think after I use these calculators for literally years, I would know where everything is.
It's okay.
But I still don't, it takes me forever. I struggle. And then do we need to put like the, in and stuff, or is it just the fraction? No, okay. So we're just putting like the fraction, right?
Yes,
Okay.
squared. All right. What did we get?
I got 96.74.
Did
I
y'all
got-
get 96.04?
Yep.
That's what I got.
Yay!
Yay! I actually understand what I'm seeing.
96.04. So if n, look, 96.04 is less than or equal to n, what sample size do we need to pick then? Because if we reverse this, it's always a little easier sometimes to read an inequality when the variable's on the left side. If we reverse this inequality, that means n is what to 96.04? Is it less than or greater than?
What's great?
It'll be greater than, because look, the alligator mouth is eating the n,
Yep.
n's bigger. Alligator mouth eating the n. Okay.
I say left.
So-
That way how you get it to like,
n's
Like
greater than or
left.
equal to
or,
96.04, so what sample size do we need to pick? If n needs to be greater than 96.04,
Can we do any or none?
well, we'd obviously want to do the smallest possible that's bigger than 96.04, which would be what?
96.5.
No,
97.
97.
Oh,
You can't survey a .04 person. Okay, so you always go to the nearest
My bad.
whole number. It's
My
okay,
bad.
it's okay.
I really
All
thought I
right.
said something smarter than I was like,
No,
oh,
it's
no.
okay. It's okay.
No, I'm gonna go
So you always go up a person, basically. You always round that decimal right up to the next whole
So
number,
you
okay?
always go up a person, even though it's .04?
Yeah, because you can't do.
You can't survey 96.04 people.
Right, but I'm just saying you can survey.
I can do
less
whatever I
person.
want.
You shouldn't do that.
And
You
cut
should
somebody,
always
cut
go
little pieces off.
If we survey one less
Cut a toe.
person,
up. Yeah.
Cut their toes off.
What?
Pinky toe.
Then-
That's what you're
Just
supposed
be
to
like a fourth of a person. Like a
We-
little.
Because like without somebody telling me, I would automatically round down.
since it's always gonna end up being like n is greater than or equal when you flip it around like this,
Right.
this value, you always round this up a person.
Alright.
I don't know, you just do that. Cause you can't survey a .04 person, so just to answer this in context then, to estimate the true proportion of students with tattoos. Did I spell that right, or is it double T? It's a double.
It's double
It is
T.
double T. Silly. I knew that wasn't right. To estimate the true proportion, that's a T there. That's weird. Of students with tattoos, we then a 0.1. This cap keeps falling off. Margin of error, we need to survey 97 students. Done. It's quite possible that on the test with the FRQs, you may calculate a confidence interval in part A of the problem, but in part B of the problem, you have to do a sample size. Like this, what we just did. And it may even tell you in that instance to ignore the p hat that was given to you in part A. It may be that you're surveying, it may be that you're asking something similar to what they asked in part A for the confidence interval. I don't know. It's possible. It's also just possible that this could be a multiple choice question anyways. And which in that case, you don't have to worry about interpreting it, but you want to obviously get the right answer for the sample size, which would be 97 in this case. Okay. Questions? Your margin of error would potentially be more than 0.1, John, if we survey 96 students. That's why. We want that to be just right. Now, if it's truly not really close to 0.5, our actual margin of error may be well below 0.1. We really don't care as long as it's less than 0.1. Okay? It's possible in a real world scenario, you really don't have to have that many to survey. But this will for sure give you that. Will fit those conditions. That's the gist of that. Questions on that?